Hey guys, welcome to this channel. My name is Danny, and thank you for watching this video. In today's video, I'm gonna give you a example of how to use a lazy stream, how to use a pass-through stream uh, for one of the uses, which is a lazy stream. So just look at this slide. And sometimes just let's say there's a scenario. Sometimes you need to open many files to operate on many files simultaneously, like WinRAR or WinZip tools. You have to have a good performance, so you have to deal with a synchronous and parallel. So that means you have to open up many files at the same time. But for the specific operation system like Unix and Linux or macOS Windows, the number of the file descriptor is the resources of the operation system. The number of the file descriptor is limited based on the operation system. So how to open up more files, or just use the file descriptor effectively. So just give you a method to leverage, how to leverage pass-through stream to do a lazy readable stream or lazy writable stream when you want to read data from the underlay from your file or specific files, and you want to write your data to the file systems. So start to make sure that the number of the file descriptor you used is keep lower. So what do you how do I what do I mean by lazy stream? So that means you once you created some of the stream just automatically running. So that means for example, you have 1,000 file to be open up, and if you create 1,000 streams, readable stream for corresponding your specific files, that will be the huge waste, and so you should try to grab a new method to push back the creation of the streams while the real data is truly processed. So that means that when the real data are being read or written, the moment you start to apply for the file descriptor, and then you create the real readable or writable streams. That is called lazy stream. So you don't need to create a lot of streams ahead of time, ahead of the real data is really coming. So that's the theory of the lazy stream, and we are going to head over to my snippet. Hey guys, let's go through this example. As I said, so you can use pass-through as a lazy stream. So here we have two two files. One is lazy stream class definition, and one is a main program. Let's take a look at the main program first. So the purpose of this program is just grab a folder, a specific folder here, and iterate with every file in this folder, and just read the file data from every file. Because the file descriptor, the number of the file descriptor is limited for different operation system, so we have to use a lazy stream technology for them to get optimized. So here we just give it a iffy function here. So we read file, and that takes a directory name, and which is this one as argument. So fs.read the directory. So read this directory, and when it's done, this callback will be executed. So for this callback function, it takes these file names as an array. So within this callback function, I just grab file name at this array, and give it for each function for this every cell of this array. And you can see for every file name, we create lazy readable stream, that which definition is in another file we'll talk about later. And when it's instantiated, it needs file name and this callback, another callback as an argument. So this callback function, you can see here, is return blah 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 fs create read stream. So the purpose here for this function is just when you instantiate this lazy readable stream, you give it a definition of the function, but at this moment, this function is not executed. So we just push back the execution of this function until the real data comes in. That's the meat, that's the kernel of this whole program or snippet. So next we print out a console log this lazy stream created for a specific file, for every file name, for every file, and then we just give it a set timeout. So we're gonna go ahead and explain it. So the timeout is 10 seconds. Here we just simulate the duration, the period between this one's execution and the real data, the moment that real data comes in. So here is a simulation for this kind of a scenario. So set timeout and give it a handler, and so just define a lazy readable stream on, and to define a data event, give it some of the console log, and also the data length will be accumulated or added up, and also give it the end event. So that's a pretty simple for set timeout this asynchronous snippet. And let's get back to our definition of the lazy readable. So here we define a lazy readable, and that extends passthru. And here the common constructor here, and just remember this callback we just talked about is pretty important. So we just add this callback to this property, internal property underscore callback. And then it just if callback has some of the parameters, so we just put it in to another properties here. So move on to this one. This the underscore piped equals false. That means just give this stream or this instance a flag, a Boolean flag, and a string name and the file name. And this the string name equals the file name. Just give it a name and console log in constructor. So this is a pretty common and constructor. And let's move on to the underscore read. Underscore read, we console log in underscore read, and then this the underscore pipeline. So that means if not true, if this variable's value is false, so not false is true. If true, that means this block will be executed when only once at the first time. So then we just put this value to true. So just only this block will be run only once at the first time when the program goes to, or logic goes to underscore, goes into this underscore read, this block will be run once. And look at this new stream and this callback. At this moment, our real callback underscore callback call is executed. Remember, we're intended to push back this callbacks running. So here we ran this callback and we got our new readable stream, because when you go back to this function return value is fs create, so they create new readable, create readable stream, right? So back here, just we give it a name, and this the new readable stream as a new property of our passthru class or instance. So then we pipe the new readable stream into existing one. So we pipe two streams together. Then the flow goes into the whole pipe. So then we define the pipe equals true. We just trigger the trigger this, or just this pipe equals true. So we never run this block again. And this new stream on, give this new readable streams data event and console log blah 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 to show our whole process here. So that's the underscore read is all about. And then we define underscore destroy. So console log destroy, and then when this passthru instance destroyed, and the new stream will be destroyed. So we try to do some cleanup for the whole pipe we created and delete this property. So just release, free up the memory and free up the resources and call back again. So the destroy and the score destroy just do some cleanup for the whole pipe. So that's a definition of our lazy readable stream inheriting passthru. So the important or the key point of this is this one. These three sentences, we just push this callback running or execution back at this moment, and we pipe two stream together, and then data will be flows in automatically. So, and we just decrease the period of using file descriptor, right? So the whole purpose of this program just decrease the period of using or taking the files descriptor. So that's the two snippets are about, and we run it right here. We run again. Then we look at this output. Just here is just waiting for the 10 seconds to time out. So here we just look at the whole output here. So you can see for the first in construction, we have several files in this folder, right? And we iterate the whole file, all of the files, and construct or create lazy readable stream one by one. In construct, create lazy readable stream, create readable stream, da 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 da. Then in underscore read. So that is the first time the program goes into the underscore read, and then you can see that lazy stream data event, file event, and file size, and then 6K and 64K and for every file. So you can read file content of every file. You can see there, right? And then scroll down to the end. Reduce, blah, 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 and then stream destroyed. So the whole stream destroyed. So you can see the whole process. I run it again. You can see there's a pause, right? The waiting for underscore read to execute in 10 seconds. So that means after 10 seconds, even we created the readable, our lazy streams, but the lazy stream doesn't have any data until the 10 seconds passed by. Okay, that's it for this program. For this program, thank you for watching, and I hope to see you in the next video.